Good morning, everyone. So I'm happy to see everyone today who came in the morning for the talk. So I'm going to cover the topic which I think is not sometimes covered enough. Like we often talk about the approaches to building pipelines, about tech, about frameworks development, but sometimes you kind of skip this moment, like what happens next after we already have some solutions and pipelines running in production. And I think it's also important to talk about some kind of failures on the way of building these things because basically it's a path to growth and development in the future. So yeah, I'm working as engineering manager at Captify. It's a UK-based company with engineering team between Ukraine and London. Also, I've been data engineering lead of Women Who Code Kyiv community, and I often speak at conferences and meetups. So I'm going to cover a little bit of the business domain because the experiences about the pipelines and the issues that I will cover are related to my current job. And our business domain is AdTech, and I think it's kind of also important to understand better the business domain in order to build better technical solutions generally. So AdTech is more like an advertising on steroids. In the past, you could remember that you could see an ad on TV, and it was usually kind of targeting the broader audience. And that's why you could see something that is not like related to you, while AdTech allows to have these methodologies and tech that would allow to deliver the right content to the right users at the right moment. Basically, we are kind of targeting the right users, and we have a win-win situation because the brands that want to advertise their stuff, they're looking for potential consumers. And we as consumers are looking for something that basically suits our needs. And therefore, it's kind of more interesting for us as well to see the ads that are targeted to us and they kind of show what we actually need. So in terms of tech, we use Scala mostly. And other frameworks that we use is Apache Spark for batch data processing, Kafka and Flink for streaming data processing. We use also Amazon S3, HDFS, and Google Cloud for data storage. And we recently moved from Impala for reporting and analytics to Databricks. And we're kind of also slowly moving towards running some pipelines in Databricks as well. So now we can imagine a situation that you have your pipelines running in production. What happens next? Like, I don't know how many jobs you actually have right now at our company, but in my team, we have at least like 60 workloads for 4 members of the team, which is quite a lot. And we have multiple teams, so basically we have hundreds of jobs running in production every day with different schedules in both batch and streaming format. So first of all, types of issues that you may encounter in production. I think the most common one with big data pipelines is low performance. And this could be both due to kind of not being able to predict the amount of data that you are going to receive or the data formats. And just because sometimes we have increase of the data and unpredictability, so low performance is a common issue, like whether it's Spark problems with drivers or executors or just slowly running jobs. Another one is with data source, basically errors with data source. So we work with different data providers, and it's often the case that the pipelines ingest the data from somewhere, and therefore there could be issues either on the side of the data providers in providing this data in specific formats or on kind of our side to parse this data properly. And human errors, which are also very common ones, and kind of no shame there as well, like running some wrong queries or making a mistake while working on some pipeline or not accounting for specific risks and therefore having failures in production in the end. So yeah, all of that happens, and the stories that I'm going to cover kind of match some of the types of these issues. So first story is called Unlucky Query. So what happens sometimes is someone has the rights to production or kind of runs the query in production environment instead of QA environment, happens sometimes. So the case that I'm showing is around kind of dropping a huge period of time for the data. So we had this data feed called user profiles, where we built kind of segments or profiles of the users. And those were covering different demographical data, for example, gender, age. and that was called like a profile. And the feed is not that huge, which was good news. But bad news is like storage of 13 months is still like a significant one. And the users started to complain that like the data disappeared, and they usually run reports whether like monthly basis or yearly basis. That's why we have 13 months to kind of cover this period. So what we needed to do is basically reload the data, but we needed to do that quite quickly. So what happened in terms of tech is that we have this pipeline where we read the data from HDFS. Another team supplies these user profiles. My team is just kind of working on delivering the data to the analytics or the users. And Apache Spark job is kind of running, reading this data, making some small transformations. As a result, we have Parquet files, and those files are then sent to Impala. Impala is not a storage system, it's a query engine, so it's kind of similar to a database in terms of experience for users, because analytics used Impala in our teams to basically run SQL queries and do reporting. But in reality, Impala is actually a query engine that runs on top of HDFS. So basically, it just shows the data in the form of tables, but in reality, your data is stored in Parquet files as well on HDFS, kind of behind the scenes. So basically, this job is just moving files from one HDFS to another, just by applying the format of tables. So the good news is that another team is still kind of delivering the data. So we do have the data in the first part of the pipeline. The problem is that we don't have it in the end of the pipeline, and the users are not able to see that. So like we have a backup, so it's a good situation. We just need to reload the data gradually. So we have the 13 months. It looks like this. We have Parquet files partitioned by hours, and we want to just reload from one HDFS to another where we have missing data. So yeah, kind of the situation where you want to revert back the query, but you can't do that. So here the situation is not too bad because, again, as I said, the amount of data is not big. Like it's not terabytes even of data. But the issue is kind of the limit of the resources that we have, and that's why we needed to approach the reloading mechanism in a more kind of smart way. So what we have in most of the jobs that upload the data is this so-called period to load, which is usually 5 days. So the job runs every day, checks the last 5 days, refills the data, and pushes the data to Impala. And in this case, like the most simple approach here would be just to put 13 months here and reload, just run the job and wait till it finishes. But basically it doesn't work in this case because, too much data. And for Spark, the better case is to kind of distribute it somehow among executors instead of just reading all of the data on the driver. So the job was like really struggling to read all 13 months. And we didn't really want to work with corrupted state in case that the job fails and you don't know like which month was loaded and which wasn't. So the solution here was to do that gradually. We decided to take 1 month period, which is fairly safe. And it's also good that the job works kind of back in time because we check the latest data. And for users, it's more important to have the most recent data. Therefore, as soon as we loaded like the last month, they were much happier because they have like the fresh data, they have the last months, and they can work with that. While we could gradually load all of the older months, and like after 3 months, the users don't even care because luckily it wasn't the period of some like yearly reporting. So they were just happy with these 2-3 months, and then we continued uploading the last ones. Another issue was that the data is kind of gradually growing over time, and therefore it was harder to upload the newest months because basically we just had more data in those periods. While kind of older data, it was easier to reload, and at the same time kind of less pressure in that. So that was a solution to that issue, but with some feeds, it wouldn't work maybe like 1 month. Maybe the period could be even smaller if the feed is kind of bigger. So in this case, we kind of saved the day, and basically in reality, we had the situation repeated twice with the same feed, which was weird. So at least the second time we knew what to do straight away. So the second story is about missing data. I think it's quite a typical situation when you have a huge pipeline with multiple steps that at some point when you stop seeing the data, you need to kind of be a detective and investigate where exactly the data started to disappear. So we had this pipeline. We retrieved the data from one data partner, and the data partner just drops the data on Google Cloud. We have the job which basically moves the data from Google Cloud to Amazon S3 code extractor, because we want to have kind of more control of the data that we are reading, and it's easier to debug if you have it stored like in your storage system and basically backup. Because in case data providers do something with the source data, we already have the amount of the data that we need on our Amazon S3. And we have the job called data cost attribution, which is a very heavy job with lots of steps. And this job just dumps the data on HDFS. So in this case, what happens is that we suddenly stopped seeing the data in the end of the pipeline, which is HDFS. And that's why we needed to kind of debug every step of the pipeline to figure out what happened and where exactly the data disappeared. So my usual approach to that is start actually from the beginning of the pipeline, because sometimes there could be like missing data from data providers, like they had some failures on their side, and we need to check first if it's like our side failing or their side. In case it's kind of their side, it's a bit harder because there is the whole process of communicating what to do around that. But on our side, we will have to apply some techniques and actually debug. So the problem that we discovered, it was on actually the side of the data provider, is that they suddenly renamed the columns, and they didn't kind of say anything about that, didn't send an email. And for us, it was a huge surprise because it's quite a huge data provider, kind of famous one, not gonna call names. But it was a surprise, and here I kind of anonymized a bit by putting X into X's, but in reality they just put like another word in front of all of the columns' names. So not cool at all. And what we need to do is now we have around a week of missing data, because our job was targeted to actually choosing specific names of the columns, and that's why it didn't work. Like the job just checks the data, doesn't see the names of the columns, skips, nothing happens. So that's why we don't have any results. So the solution should be quite simple, right? Just rename the old columns. Let's switch to the new format, because that's the format that they are going to like continue to work with, and reload the data for that missing week. So sounds kind of simple. So what we did instead was trying to approach the situation that we have now, kind of two versions of the data. Like I mentioned, we have a missing week of the data with kind of new column names. But we have also previous year or so with the data, and therefore we have old columns with kind of X, and we have new ones. So we don't want to just reload the whole year or do something like that. That's too heavy computation. We want to approach it in such a way that in case we have different types of names, whether in the future or right now, we can approach that kind of in both sides. So in this case, you can see that if we just use regular expressions and we see that we have old name, we just rename to a new one. If it's a new name, we just pick up these columns and work with them. And therefore, our job is able to kind of pick up the new columns in Select, in Spark, basically, and we can work with that. So in the end, we have just the columns renamed, kind of like the final result, and the users just see the new names, while in reality, behind the scenes, we kind of do this small renaming, and it helps us to work with two types of data, or kind of two versions of the data without the need to reprocess. So the next story is called divide and conquer. Basically, sometimes we have issues with Spark jobs when Spark is not able to process some chunks of data. And it's basically around kind of the proper architecture of the job. And usually it's on the side of partitioning, because we can have like two big partitions, and Spark is not able to handle that on the driver. And it's not the best approach usually to basically have those big partitions. So the situation that we have had in the past is kind of this Spark job, which is called state because it holds some information for a period of time. And we had to rerun it for, I think, a couple of months. And therefore, the amount of data was huge. So what we had is kind of this processing time partition in the source. And in the end, we have this created after some date that we process. So every day we run this job, do some filtering, aggregation, and mark the date we kind of created. Like today, we have a new state. So the problem is that the job started to fail at some point. And the simple approach, usually when your Spark job is failing, you just kind of drop more resources for the driver, or you add executors and see what happens. And over time, we saw that it's not helping. Like, it continues to fail and it continues to get more and more resources. So it's not the best approach just to go with that. We need to kind of do something differently. Also, processing became very slow. So it took like 3 or 4 hours. Then it kind of went to 6 hours, even with more resources. So it wasn't like acceptable for us, because we had a bunch of pipelines downstream from other teams to pick up our data. So they were not happy with this slow processing. And in the end, because of the large partitions, we had large Parquet files. And it's kind of this classic big data problem of either small files or big files. So we have this like big files problem. So all of that is like not acceptable, just to throw resources and leave it be, because sometimes job kind of successful, sometimes it fails. So we don't want to be in that state. So what we did is create a new partition column. In our feed, usually we use kind of dates and hours for partitioning, because we want to read the data for a specific hour, for example, and it's easier. And sometimes we have additional partitioning columns, for example, the ones that have kind of a limited set of values. Like, it could be gender, it could be country, because it has a limited set of values. In this feed, we were not able to find such columns, so the usual approach is, let's just create this column. And in this case, by hashing the values for URLs and domains, which are usually unique values, we can create this partition column, which is called seed. So with the help of this column, we can create smaller partitions and just kind of write the data faster. And after that, we can write this new state. It's going to be partitioned differently, and therefore all of the jobs that are consuming data downstream should also kind of adjust to this new partitioning style, as I mentioned, because we have smaller states now. So how it looks like kind of technically, we have this, in the past, we had this big Parquet files processed by time, and we have this processing time as a partition. And now we have created, and in each of the partitions for kind of the date that we have buckets from 0 to 9. Because we used hashes, the data is distributed more evenly than it would be if you would have some kind of natural column, because sometimes, for example, if you would distribute the data by countries and you work even with 3 or 4 countries, there still could be a skew in the data, because you might have the data more like for one country and less for another. And that also sometimes causes the same issues with larger partitions. While here, you can kind of work with more even distribution, because you just kind of apply the number from 0 to 9. But in the end, why it's kind of divide and conquer, we have the same states in each of the bucket, but they are divided into smaller chunks. And we can approach the same state and use it downstream, but just in smaller parts. And we actually then apply the same approach to other jobs that operate with this kind of snapshot of the data, as we call it, because it's much easier in reality to work with the data that is recent, like 1 day or a few days. But if you have to work with a snapshot, which is 1 month or longer, sometimes you need to find these techniques to kind of decrease the amount of data you work with. So yeah, that solution worked, and we kind of took this approach as something to use for in the future in case we have any issues there. So the next story is called the Catch the Evolution Train. So in every company, I think there is some kind of like a visionary person, an architect, or someone who has some ideas in terms of how we are going to develop, maybe like new tech we want to use, new frameworks. And in my company, we had an architect who created kind of this idea of let's move to data mesh. So data mesh, just to give the general idea, is basically the approach to how you kind of store the data and show it to the users. You have different layers of the data. You can have sources, batch or streaming, and you can do anything you want with that data, and you can store it like on any storage system. In terms of the layers, so you have this bronze level, which is ingestion tables, as we call them, or raw data. This is just the data that you read without any transformations. There could be some like renaming of the columns, but overall is just raw data. Then there is a silver level, which is more refined, so you can do some data cleaning, maybe some filtering, but nothing more than that. And then there is like feature or aggregated data store where you can create some kind of summaries, run some reports, maybe do some, for example, counts or build some formulas. So that's usually around kind of analytical part. So why it's important to have these different layers of the data? It's basically targeted to different types of consumers of the data. So when you have a large pipeline, which is kind of spanned between multiple teams, you might have someone who wants to consume raw data and work with that data and see what you receive directly from data provider. And you might have the users who want to work only with some aggregated data. And therefore, they want to have a vision, for example, how the data change over time. Like they can give some recommendations like we have from our users that this is what we want to run in terms of formulas, but we also want to see raw data. So the problem was that at some point, the analytics team, the users of our data, reported that they have some missing columns from the source. And it wasn't like an error in the job, more like that they requested just to add new columns. And then we thought that this process of kind of adding columns on requests is quite tedious because every time you need to like get this column dragged through the whole pipeline. And it's not convenient at all. And also it's kind of against this data mesh principles because they didn't have visibility into raw data. They only got the results in the end of the lots of transformations. Another thing which was the problem was dependency with another team. So at that time, multiple teams were already kind of on this evolution train, trying to migrate to data mesh, trying to migrate from Impala to Databricks. And they applied this kind of knowledge to that by building these layers of data. And we were a bit behind them. And also we kind of stopping them from migrating from Impala to Databricks because it was like one of the last pipelines or something like that they needed to check. And there was a specific timeline, and the users needed also some time to check the data and run their reports and adjust them. And yeah, we have unhappy users from the analytics team that don't have enough columns for reporting. They can't progress with migration. They can kind of show this green light that everything's fine, let's do that. So everyone's unhappy, everyone's stressed situation. So what could we do? We already have some kind of acquaintance with this pipeline called data cost attribution. As I mentioned, it has multiple steps. It's one Spark job, but this is all kind of the steps within the job. So we receive the data, so-called log-level data. In advertising, we call log-level data user events. So when you as a consumer are kind of viewing the website, you can click on the ad, you can kind of buy something. So the types of events that happen usually are clicks, impressions, and conversions. And we get this data, and as you understand, it happens every millisecond. That's why the feed is quite huge, because it's kind of almost real time. Then we ingest this data, we apply some mapping to create the proper schema, we do some enrichment from the database because we need some additional information, and we do the transformation. The transformer part is the heaviest one, and in the end, with these columns, we want to kind of, if we want to add new columns, we need to add them to the mapper, and we need to add some transformations, if necessary, to the transformer. And again, the job is quite heavy because it checks this log-level data for the last 5 days, which is really a lot of data. And it checks our so-called segment feed. So we create these segments or audiences of the users that exist based on some different parameters. And in the end, kind of the business idea of this pipeline is that we want to see if the brands, the targeted specific users, are actually kind of got these users to watch their ads or do something with them. And we just calculate some data costs, but it's just fairly small step there. So we store this data in the end, and the users don't see those columns, and we need to kind of drag them through the whole pipeline. And the thing is that this pipeline kind of consists of multiple jobs. The one you can see like on the right side is data cost attribution. But before that, we move the files from Google Cloud to Amazon S3, and then we expose this data in Impala. So you can see that there are these two places where there could be like visibility of the data in terms of data mesh. First one is Amazon S3. That could be like this bronze level when we just have raw data. all the columns that the users ask for, and then we do some transformations, maybe drop unnecessary columns, and that's it. And that's when we have the data on HDFS. So what we decided to do is, instead of just kind of dragging these columns and continuing with working with this pipeline, we decided that we will kind of make another step in this pipeline to basically make the data available for the users. So what we have in the source, as you saw this data already, the same data provider, is we have 26 columns in our attribution job, but in reality, in the source data, we have 82 columns. Therefore, there are always going to be some kind of data missing for the users because, it's 2 times more columns in the real data in comparison to what we do next to it by choosing only a specific set of columns. So what we did is actually we asked feedback of the users, which was a great approach. Like, do you need all of these 82 columns? They chose around probably 50 or 60 columns, which is still like much more than 26. And we created this separate job, new ingestion job. We just read the data from Amazon S3, and instead of going Impala route, since we were migrating to Databricks, we just dropped it to Databricks via an autoloader. So now the users can see the raw data. It's like according to this data mesh concept, and they can see the bronze level of the data with all the columns that they requested. Actually, we applied later this solution to all of the data providers. So we had kind of this attribution pipeline working for 3 data providers in a bit different ways. And that helped to migrate. But at the time, what was kind of not the best decision is that we did it a bit late, because we did plan to do it sometime, but since our team was not kind of onboarded at the time with these changes and evolution that happened to other teams, we had to do it more like in a way that you need to do it like for tomorrow, and it's very urgent. So what we needed to do is simply write the data with partitions for event date and event hour, and apply the mode override, and we have some destination paths. So it looks fairly simple, but in reality, it didn't work. So what happens is that we have different types of events, and this data provider doesn't deliver the events in one file. It delivers the events in 3 files: clicks, views, and activity. And basically, because of the partitioning technique for event date and event hour, what happens is that our job checks the last hour, picks up the data from this hour. Turns out that clicks were latest, for example, and then it just doesn't check any other events. And that's why in the result, we have files only of one type of events, while we were kind of expecting to see multiple types. So not cool. And at that time, like how I discovered this issue was that when I was running it multiple times, I noticed that different types of events kind of turned out in the end. Sometimes it's clicks, sometimes activity, and that's how I figured out that maybe there is some issue with kind of time partitioning here. So the issue here mainly in the way that the data source is built. So as I mentioned, we have different types of events, and they can have different timelines, and some events are connected to one another. So in this case, business domain kind of really matters, because in advertising, all of the events that users are making are connected to one another. That's why there is this schema. And the highest ratio of the events is usually impressions. Then there are clicks and conversions. But basically, there are no clicks before impressions. The impression should happen first, only then click, and only then conversion. And that's why we kind of have this dependency between events. So what we did is simply just drop the data in different folders, which is a simple solution. And we did that because we also got feedback from the users that they are not actually using all of the events in one file. So why kind of struggle and synchronize the dates with the events if we can just drop the data in different tables on Databricks, and they can use it just like that. So that worked in that case. Another story is called cleanup type. So basically, in our company, we just entered this phase of let's drop all of the old pipelines. And I think it took like a quarter when people just started dropping everything. And there were like pull requests with 100 files dropping all of the jobs. So yeah, like let's redo everything kind of thing. So the issue that we have is this job called ingester. We receive the data on Amazon S3 from some data provider, and we have kind of corrupted data. Like we have something weird in Databricks, which is then picking up the data from Amazon S3. And the weird thing is the error that happens in the job can convert binary data type. So what we thought at that time, okay, probably the format changed for some column. We can do something similar to what we did in the past to kind of let's check some different formats, track two versions of the data. So it was kind of a weird issue. So like it's logical, let's adjust the pipeline to this new data format for the column. Let's reload the last 3 days and just relaunch Databricks autoloader, which actually kind of automatically checks if the data was dropped and then refills it. So it's quite convenient. But then we looked into our job. And since, as I mentioned, there was like this huge cleaning period, we just thought, why not improve what we already have? So as I mentioned, we have different types of events that are connected, but the users, they are not actually using those events in kind of one huge report. Therefore, we don't need to have this connection between events. So right now, like what we have is impressions are built out of video events and impressions. Conversions actually consume 3 feeds, and that makes the job very heavy. And second thing, it's really hard to maintain because it happened that this job was built by another team, which was transferred to my team, and everyone in my team was like, we don't know what to do with that. It's really weird. So they are trying to read some code and understand that, and it takes a week to debug and understand on which step of the pipeline it happens. So what we thought is maybe we need to kind of rewrite that because it's been a while when we were struggling with this job. So like no reason to just maintain something that was in the past if it no longer works for us. So yeah, we gathered feedback from the users and we applied similar approach to different tables and different feeds. We are still on the way of kind of rebuilding this pipeline and negotiating with the users because actually like over the years that they've been using the data, they just got used to this format and they got used to the thing that they can use columns from different kind of types of events in other feeds, like for example, video events, columns, and impressions. And but at the same time, the time synchronization didn't work for them. So in the previous slide, you could see that how we actually connected these different types of events is by synchronizing the time, kind of finding this link between each impression and conversion. So it didn't work precisely in reality. So the users, after a year, suddenly complained that, well, it wasn't like the most precise and we just run reports completely differently and we do our own joins. So we wondered, why do we even have to kind of maintain this complexity if the users also don't use it? That's why we kind of applied this approach as well, similar to another feed. And it was like a great feed to do that because part of the kind of rebuilding and rethinking the pipelines that we already have. And overall kind of conclusions, because just one thing is to have kind of failures and issues and completely different thing is to learn from that and make some conclusions. So first thing I want to talk about is prevention mechanisms, because I think that kind of learning from mistakes like that, you can actually build something within the processes of the team or your company, which would help to basically run the pipelines better and build the new ones as well. So the first one is kind of set up these clear expectations with the users or stakeholders. So as I mentioned, we had some transfer of pipelines between the teams, and we didn't always have feedback from the users. And now, like after 1 year of using the data, they suddenly say that something doesn't work for them. So if we would do that kind of from the start and set up clear expectations, what works for them and what's not, then it would be kind of much better. And it's the same thing for even kind of working with the schema improvements. That's what we are applying as part of the process as well. So if we have users that have specific requests on the columns to use, we just like create a table for them and tell them to mark these columns that they want to use and then work from there, because it's already like this step is documented and you all agreed on something. Another one is observability. So right now we have monitoring on using Prometheus and we have Grafana dashboards. But at the same time, our alerts, which kind of the team discovered, are not as granular as they could be. So we do see, for example, missing data, and that helps to fix issues faster. If you see that your job has missing data, no need to kind of debug the job itself. You know that something is wrong with data provider and receiving the data. Another thing that we are discovering right now with using Databricks, we're not using it as kind of runner for Spark jobs like runtime, more like just for discovering the data and storage of the data. And therefore, we are looking right now into kind of tracking missing data via Databricks and creating some metrics from there. And also data gaps creation, kind of tracking, because sometimes that happens as well. And refilling data gaps is a bit harder than just reprocessing the data. Another prevention mechanism is basically distributing the load of the job that you have. So in the beginning, if you already know that there could be potentially a huge load of data, or even if you don't have a view at all, it's kind of better to build the approach in such a way that it could either scale, or you have already like smaller partitions in the beginning, and that's why you don't need to do any seed columns and then adjust any pipelines next to actually read your data with new partitioning mechanism. So in that case, this is something that you can kind of predict on the stage of building the architecture of your pipelines. And also planning kind of major changes like evolution of your data more carefully, including kind of these dependencies between the teams, which is we are trying to do because we do have kind of forums of discussions. Like we've created our architectural team where people who are interested in architectural changes, they can discuss them. Like, for example, right now we migrate into different databases and we discuss that during the meetings, like how we're going to use that, how each team is going to reference this data. And also we have Scala chapter, as we call it, because we have different teams using Scala, and therefore it's also a forum for different teams to connect and discuss the techniques that we use for Scala, like upgrade of the versions, which is also important, or approaches to building pipelines. So kind of that helps everyone to be on the same page for multiple teams, and also we kind of also always trying to update the teams by running technical conferences. So it's like within the company. So it's basically just the processes thing, but it's very helpful. And overall conclusions is that data setup is always changing. As I mentioned, we have for some pipeline situations where the amount of data is growing, where the data providers are suddenly changing the format or the names of the columns, which often happens. And that's why it's important to kind of build more robust pipelines that could be adjusted more easier or scaled in case something changes. And again, as I mentioned, observability helps with that. Another thing is that all the errors can be prevented. Like you can never have this proof system where like nothing ever happens. But at the same time, right now, kind of looking back, I see that our systems are becoming better and better, and we have production issues less often by making some improvements which kind of span multiple teams. Like, for example, that evolution to Databricks, because we had issues with Impala that didn't really work for the amount of data we work with usually. And therefore, kind of switching to Databricks already decreased the amount of errors that we had with Impala. And also, I don't think that there is like a golden standard to how you approach building data pipelines. There are multiple approaches on how you can do that with different tools. So you can choose different frameworks, or you can choose kind of different approaches to how you build the architecture of the pipelines. But I think it's also kind of useful to learn from other companies or other people within the community to understand how they are approaching the problem. And yeah, data evolution is hard when your data is changing, like new columns, new frameworks. It's always hard, especially if it's spanning multiple teams. And it just happened so like that the last year in my team, we had to approach a lot of issues like that. But I think it's also kind of an interesting challenge to grow technically. So thank you for your attention. Here's my contact info. I'll post my slides in Twitter, and also here's my GitHub, LinkedIn. Also, my slides can be found on Speaker Deck, and recently I created a course for Manning on Scala. So if you know someone who's kind of starting out in Scala, you can recommend them this course, because I tried to kind of build the approach similar to how you work in the company, where you need to design stuff, then you need to implement something, and then kind of test the solution. And also, I'm from Ukraine, and therefore, if you want to support Ukraine, you can always make donations. This is something that we always kind of value, and we say that there is no such thing as kind of small help or small donation. So thank you, everyone.